Let's do this problem from your lab assignment, section 6.2, problem number 1. They want us to find the volume of the solid obtained by rotating the region of the given curves specified about the line. So we have a curve y is equal to 8x cubed. We have another one, looks like it's going to be a line y is equal to 8x. And we want x to be bigger than or equal to 0. I'm going to hope that they're going to intersect somewhere. We want to rotate that about the x-axis. So we have a cubic function. So the general shape of a cubic function looks like it goes, kind of looks like this, kind of like an S shape, or well, it's a cubic shape. And we have a line. So this looks like, these two graphs look like they're the same. They're the graphs that we're looking for. This is not the graph that we're looking for. This looks like it's a cube root or something, or square root, so that's not going to work for us. But this looks like the line and the cubic function, but we want the area to be bounded by those two graphs, and so this triangular region is not bounded by those two graphs. This, on the other hand, looks like it has a line and that graph, so I think that'll work. So we have our graph, and then now we spin it around the x-axis. So if we spin it around the x-axis, imagine the line being the outside, and imagine this cubic function being on the inside. So there's a space between the area and the axis of rotation, so there's going to be a hole in our cuts. So this is going to be a washer method. So the first two choices here looks like they're disk, and that's not what we want. These two are both washer methods, so it's going to be a choice between the third and the fourth choices. Now if we look at this graph again, the outside being spun around looks like it's the line, so this is going to have a cone shaped feel for the outside, and the inside is the cubic function. That's the third graph. If we look at the fourth graph, we see the outside looks like it's curved, and that's not what we want. So our choice is going to be this graph where the outside is a line being spun around, we get a cone, and the inside is curved in, and so there's a hole in the middle. Okay, so that's the graphic representation of the volume that we're looking for. Submit. Looks like there's a question here. This creates a washer. There we go. All right, now let's try to submit. Are we still missing something? Oops. We submitted, but I didn't check this one out. This is the graph that we're looking at. Now let's try to submit. Okay, finally got through that. Step 2, the inner radius is going to be, so since this is the washer, we're going to have an R out and R in. The inner radius of the washer, if you look at the washer, it goes from the axis of rotation to the edge of the region. The axis of rotation to the edge of the region, that's the cubic function. So the cubic function is going to be our R1. The cubic function again was 8x to the third. So that's 8x to the third. And the outer is going to be that line, so that's just 8x. Y is equal to 8x. So those are two radii. And now the cross-sectional area of the washer is going to be 8x to the, what was the inner one? The outer one goes first. So 8x and the whole 8x. Maybe we should write that out. So the outer radius is going to be 8x, and the inner radius is going to be 8x to the third. So if we cube this, we're going to get 8. Oh, I'm sorry. If we square this, we're going to get 8 times 8. That's 64. And then there's a pi out here. Oops, my disk method and washer method shouldn't have a 2 there. It should just have pi. Sorry about that. Okay, so back to our problem. So we have 8x squared and the minus, or I'm sorry, that's 64x squared minus 64x to the 6. So with a pi, it's just going to be 64 pi, and then we have x squared and x to the 6th. The two curves intersect at the point at the origin. So let's go back to the graph. They intersect here at the origin, and they intersect at 1 comma 8. So if x is equal to 1, they're both equal to 8. So parentheses 1 comma 8. And then now we know the limits. With respect to x, we're just looking at the x values, 0, 0, and 1 comma 8. So the limits are going to be from 0 to 1. So the area, remember, was x. There's 64 pi, and then x squared minus x to the 6th. So let's get that x squared minus x to the 6th. And then we integrate. 64 pi is a constant, and we'll just bring that out. We integrate this, we're going to get x to the 3rd divided by 3 minus x to the 7th divided by 7. And when we put 1 in there, we're going to get 1/3 minus 1/7, and then when we put 0, we're going to get 0. So this is going to be 64 pi times 1/3 minus 1/7. Now I suppose we should work to simplify this. The common denominator is 21. We're going to get 7 minus 3. That's 4 over 21. And then we can reduce. I don't think we can reduce. So we could just multiply 64 times 4. So that's going to be 16 and 24, 25, 256. So we'll call it 256 pi over 21. Oops, we lost it. Let's write it out. 256 pi over 21. All right. So that's it. Hope that helps.